Good morning and welcome to the session. So just a little disclaimer, like just before we start, you won't be able to execute the codes right now, but the notebooks will be emailed to you, and I'll also share the links of the notebooks, and you can just run it at home. So that will be the only problem. So that is the notebooks will be emailed to you, or I'll also put it in I'll give you the QR code for the notebook links at the end of the session, so you can actually run it at your home, and the rest of the things are good. So this is going to be a session on how you can speed up your machine learning and deep learning research using JAX. So how many of you have heard of JAX before? So one. Okay. How many of you are already machine learning scientists? How many of you are strong in NumPy? Alright. So this session requires prerequisite of NumPy. That's all it requires. So anybody without the knowledge of machine learning, deep learning here, getting started, beginner. Okay, one. So anybody who doesn't know NumPy? Two. So you might require, both of you might require a little of follow-up. It might go a little above the head, but that's how it happens. Just don't get overwhelmed. Now let's get started with the session. See, before that, you can follow me on Twitter at Usha Rengaraju, where I put off all the things which I do for community. And you can also look me up in LinkedIn for everything I do, so I can save time, just saying what I do. Yes, today's session, this is going to be the agenda. We'll start off with what is JAX, and then we'll start off with what are the features of JAX, and then we'll start off with the basic fundamental data structure of JAX, which is called device array. And we have a lot of functional transformations in JAX, which makes it as powerful as it is. And we'll see what those transformations are and what are the components which makes JAX one of the powerful framework which currently exists for machine learning and deep learning research. And we'll also see how JAX differs from NumPy in few areas, and I'll also show you at the end a simple notebook of how to build a neural network using FLAX. So FLAX is built on top of JAX, so it's a very basic neural network on how to solve MNIST problem, but then it's using FLAX, which is framework. There are a lot of deep learning frameworks which are built, high-level APIs which are built on top of JAX. So we'll be seeing one such API, which is FLAX, at the end of the session. So this is going to be the agenda. Now let's get started. So JAX is a Python library which tries to, it's not something out of the blue or something like this. So it's a Python library which tries to mimic NumPy. So if you take all these NumPy core functions, you'll find equivalent functions of JAX. So if you have add function in NumPy, you'll have an equivalent wrapper of add function in JAX. So it tries to mimic NumPy. So it's not something which you're going to, the learning curve is not going to be that difficult, because you're not going to learn something out of the blue. You're going to learn, it tries to mimic most of the functionalities of NumPy, so the learning curve is going to be easier for you. And so it's very simple and it's easy to adopt for certain things, but for the support is not that good, because there are very limited number of people currently using JAX and FLAX. So if you're going to getting stuck somewhere, maybe even within your company there's nobody to help you, and even outside also there's nobody to help you, until you have very powerful in-person contacts, somebody from Google who actually can resolve the bug for you. So that can be a problem there, but still it has so powerful features that it's worth the struggle to go through all the pain to write codes in JAX. So some of the features of JAX, if you take PyTorch, TensorFlow, I think all of you might have used PyTorch, TensorFlow, right? So JAX can be like 15 to 20 times faster than PyTorch, TensorFlow in certain times. If you know how to write optimized code in JAX, then the performance gain which you can get is something around 15 to 20%. So that is something huge, right? There are a lot of organizations which don't use TensorFlow and PyTorch. How many of you are aware of, how many of you are here from startups? Is there any startups which uses NumPy as your code base, or anything outside TensorFlow and PyTorch as your code base for machine learning? Native code base. So there are a lot of startups which uses NumPy and other low-level languages as their code base. They don't use frameworks like TensorFlow and PyTorch. The reason is because of the optimization power and the speed. Speed is a good. See, for example, you're going in Uber. So you're booking the Rapido or Uber or whatever it is. The booking has to be, if it has to be like 2 minutes or 3 minutes. So it's, the time is a constraint here. In service providers like Uber, Swiggy, and all this, time is a very, very important constraint. So in these things, if you want to achieve that kind of a speed, then you need to have a framework which gives you that power. So NumPy is good, but NumPy comes with a lot of disadvantages. See, NumPy you have to write, if you're going to use accelerators like GPU, you have to write a separate code. For TPU, you have to write a separate code. But JAX eliminates all of that. So you write JAX, you are given a powerful compiler called XLA. You compile the JAX code using XLA. You don't have to make any changes to your code. You can run it in any compiler of your choice without zero changes to your code. That makes JAX so powerful. You don't have to write so many boilerplate code to adapt. Even for that matter, even you take PyTorch. How many of you have coded in PyTorch using GPUs? Have you ever, you have to write a lot of boilerplate code when you have to, convert it for multi-GPU environment, and the PyTorch code to fit it with TPU, you have to write a lot of boilerplate code. For every accelerator, you have to write a certain piece of code. For that matter, even PyTorch and even TensorFlow doesn't give you that flexibility. So even for TensorFlow, for TPU, if you have to connect with TPU as an accelerator, you have to write a boilerplate code. But for JAX, you write code once, you compile it using XLA, you can use it in any accelerator with zero changes of code. That's why JAX is very powerful that way. You can call it as NumPy on steroids. That's why JAX is called NumPy on steroids. And there are other features like automatic differentiation. See, automatic differentiation exists in PyTorch and TensorFlow as well. But JAX does it in a very, very elegant way, which we will be exploring it shortly. And we also have features like automatic vectorization, and random number generation differs slightly from how it is done currently in NumPy, and how JAX does random number generation is going to be very, very, very different, which we'll be covering at the end of the session. So these are some of the features which we'll be getting deeper into shortly. So we'll get started with the basic components of JAX. So any programming framework or any framework for that matter will have the core object or the basic data structure. So JAX has that as well, and the JAX data structure is called device array. So NumPy is called NumPy ND array, right? So JAX is called device array. So to create device array, this is the syntax. I told you NumPy and JAX is like a wrapper, has got a similar wrapper functions for every functions. You can, if you want to take a NumPy code and convert it into JAX, you can convert 60% of the code by just replacing NP with JNP. So here I'm import JAX.NumPy as JNP. For if you're writing a NumPy code, you would have written it as import NumPy as NP, right? By just replacing JNP and NP, you can convert 60% of your code from NumPy to JAX. Because for every function in NumPy, there's an equivalent wrapper in JAX as well. So at least 60% of the code conversion is easier, but the remaining 40% is where the complexity comes. So this is how you will create a basic device array, which is the most basic data structure in JAX. So this is a syntax. This is nothing out of the blue. You would have all created NumPy ND array, right? It's a similar structure to that. So I'm just to give you a good view of how you create a NumPy ND array and how do you create a device array in JAX. I put it parallelly against each other so you can actually see the difference. There's not much of a difference here. I'm importing NumPy as NP, and I'm also importing JAX as JNP. So to create the fifth line is where I'm creating a random numbers, and then I'm creating this random NumPy array. I'm converting that into a JAX array by just calling jnp.array. So I have a random NumPy array, and I also have a JAX device array. So I can perform some basic operations like dot product. To call a dot product in NumPy, it's np dot dot. The equivalent dot product in JAX is going to be jnp dot dot. So 60% of the code conversion is going to be very similar, and so this is just a basic introduction of how similar it is to NumPy. So you'll get a hang of it. So you'll not see the performance gain here. If you see here, NumPy, it looks like NumPy is more faster. So you'll start getting the performance increase once you start testing it out on complex operations, and especially when you start using it in GPUs, that's when you will start seeing the performance difference between NumPy and JNP. So in this basic example is to just put JAX operations and NumPy operations parallelly against each other. So you see how how easy it is to do a code conversion from NumPy to JAX device array. One place where JAX actually the complexity begins here. Everything is smooth till now, 60% of the code conversion easy going. But the complexity starts here with this line. JAX does not allow immutability, which means you create an array and you cannot update it. So if you want to make updations to it, because we have in machine learning and deep learning, we keep updating parameters. So we need to do updation. So if you need to do updation, you will have to create a new variable. But you cannot do in-place updation in JAX. That is the whole philosophy around which JAX is structured, and so this is one of the most important concepts in JAX. JAX does not allow immutability. So here, if you're trying to do this in NumPy, it will not throw you an error, but in JAX it's going to throw you an error because I'm creating a 3x3 zero array, and I'm trying to modify the first element I'm trying to update the first element as 1. It's going to throw me an error because JAX does not allow immutability. So this is a very, very important concept, and the whole philosophy of the JAX is around this. And if at all you want to, we cannot be in machine learning and deep learning, we cannot bypass this whole array updation. You might have to do array updation. So what can I do if I have to do an array updation? I can create a new array. So I can use this at and set attribute to make an updation and store it in a new variable. This is how array updation happens in JAX. So it does not allow in-place updation. So one more thing which is very, very important in JAX is JAX supports functional programming. Functional programming in the sense you use pure functions. JAX will not say I will not run if you use impure functions. You use impure functions at your own cost, which means I will not guarantee you the same results when you use impure functions, but you're allowed to use impure functions. But JAX philosophy generally encourages you to use as much as functional programming as possible. It encourages you to use as many pure functions as possible. So what are pure functions? Anybody? Pure functions? So pure functions is very simple. Every time you give the same input, you get the same output. So you don't have any external state or something altering the state of your variables inside your program. So you take cos. Cos function is a pure function. Every time I do cos 0, I'm going to get the same output. Sine is a pure function. Every time I do sine 90, I'm only going to get 1. It's a pure function. There's no external global variable, local variable to change the state. The parameters comes through in any parameters you have, you just pass it as a parameters to the function, and the output is returned as a return value. So there are no global variables, local variables to modify the state. So pure functions, every time you give an input, the same output is returned. Every time I give cos 0, I get the same output. Every time I give sine 90, I get it as 1. So pure functions are functions you always get the same value for a given output for a given input. That is what is pure function. JAX does not tell you that, ask you to not to write impure functions. What JAX tells you is, if you write impure functions, write it at your own cost, which means I will not guarantee you the same output or same level of execution. So JAX supports pure functions, and it also encourages you to write as many pure functions as possible. So this is also a very important concept in JAX things. To summarize, 2 points you'll have to remember. In-place updation is not allowed in JAX. The second thing is JAX asks you to write as many pure functions as possible. So this is a takeaway from the slides we have seen till now. So since JAX is something which is very new to you, is it okay up to this point, or do you want me to repeat or something like that? Is it okay up to this point, right? So at any point, if you're not finding it overwhelming, I can repeat the slides. Please do keep me posted. So some of the features of JAX which makes it very, very powerful. Why is it 10 to 15 times faster? In some cases, if you can write an optimized code, it is even 30% faster. And scalability is really, really good compared to other frameworks like PyTorch and TensorFlow. When it is this powerful, what are the features which makes it so powerful? So that's where we are going to get started next. The first feature is automatic differentiation. Automatic differentiation is not something which is specific to JAX. Automatic differentiation exists in deep learning, machine learning already. So you take derivative of all your parameters, right? So derivatives, you take it, there are multiple ways you can use, find the derivatives. So you can either find it using symbolic differentiation, you can use numerical differentiation, and the third option is automatic differentiation, or you can sit and manually compute derivatives of your weights and biases also. We don't do it manually. Then numerical and symbolic differentiation has got its own disadvantages, and that's why we go for something called automatic differentiation. So differentiation is something which all of you would have learned it in your 11th standard, 10th standard thing, right? So this is a kind of differentiation which you use in your deep learning, that's all. If you do not understand specifically what is automatic differentiation, just understand that in deep learning we use automatic differentiation, that's all. So this has got more advantages compared to the symbolic and numerical differentiation. So we have the automatic differentiation in TensorFlow and PyTorch as well. But JAX does it even more with a lot of elegance. If you have written codes in TensorFlow and PyTorch, you will really understand the kind of elegance that JAX has in doing differentiation. So I'm going to write a simple softmax function. Everyone here aware of softmax? Or if you're not aware of softmax, just imagine it is some basic function. So I've written a small function here, and to find a gradient of a function, all I have to do is call grad transformation, pass that function name as a parameter. If that function has got some parameters, then I would pass it as a parameter value. So I'm passing grad transformation. Grad of my function name here is softmax, and my function does take up x as a parameter. So I'm taking passing another parenthesis where I'm passing the values. So this is all it takes to find a gradient of function in JAX. But if you have written TensorFlow and PyTorch, you will know the pain of how complex it can get, especially in higher order derivatives. Higher order derivatives is very, very easier in JAX. I want to find third order derivatives, grad of grad of grad. There are multiple other linear algebra equations and transformations which can be done Jacobian transformation, and there are several other transformations which can be done very, very easily in JAX. And for doing a third order, fourth order derivative, TensorFlow, PyTorch is going to be a pain. NumPy, it's even more a bigger pain. JAX does it very elegantly. Grad transformation is what JAX does it for doing automatic differentiation. So I've written a very simple softmax function. Here I'm using softmax because of the people recall value, but you can take any function. Take any function. The function has a parameter of one value. To find the gradient of this function, I have to call the grad transformation, pass the function name as the parameter, and if the function takes a value, here it takes an input value of x, then I pass whatever the input parameter value in another parenthesis as an input. So this is how I do automatic differentiation with grad. So if you see, let's see some statistics as well. Is automatic differentiation using JAX really that powerful? This is a statistics. So this is a statistics which gives you the execution time across multiple packages. There is a core package called AutoGrad which you can use for doing automatic differentiation as well. And there's also packages like TensorFlow, there's packages like PyTorch, there's also some combination of JAX and JIT. I'll be covering up JIT shortly. So if you see, the execution time is very less for both PyTorch and JAX and combination of JIT. So JAX is, in terms of performance, it's very good. That's what the statistics shows. And you can also compare it for multiple batch sizes. Across multiple batch sizes, JAX gives a very good performance. So we have finished automatic differentiation. Up next we have another feature coming up which is just-in-time compilation. So what is just-in-time compilation? How many of you know compilation here? Any program code you write, you compile it into bytecode, right? So the reason why we do just-in-time compilation is not specific to Python, or it's not specific to TensorFlow. It's not specific. So you do just-in-time compilation even for Java codes. The reason why just-in-time compilation is a compilation technique. It's a dynamic compilation technique. And it has got a lot of advantages, like you have less memory usages and you can do code optimization on the go. And it has a lot of powerful features. That's why many programming languages like Java, Python and many programming languages go for runtime compilation techniques like just-in-time compilation. TensorFlow has what compilation technique? TensorFlow uses what compilation technique? How many of you use TensorFlow here? TensorFlow uses just-in-time compilation. And what is the compiler which TensorFlow uses for just-in-time compilation? It uses a compiler called XLA, which stands for Accelerator Linear Algebra. TensorFlow comes from which ecosystem? Who gave TensorFlow framework? Which company is giving TensorFlow framework? Google. And JAX, which is the organization from where JAX comes? Google. JAX comes from DeepMind, so it's again Google. So it's all from the Google ecosystem, so they share the compiler. So TensorFlow also uses accelerated linear algebra. JAX also uses accelerated linear algebra. So JAX also uses just-in-time compilation technique, and it uses the same compiler, accelerated linear algebra, which TensorFlow uses. Because it's all coming from the same company and same ecosystem. But although JAX primarily originated from the DeepMind, now whatever language models or large language models which the Google is outsourcing, the Google research team is also started using JAX and other variants of JAX. But the origination of JAX comes from DeepMind. So this is the accelerated linear algebra is a compiler which does just-in-time compilation. Don't confuse much out of it. This is what it is. And the advantages of thing is it has faster, compared to the other compilers, it's much faster, it has got less memory usage, it has got better portability. So it's got a lot of advantages. And you can go, there's a lot of documentation out there in TensorFlow, code documentations, and there's a lot of content about accelerated linear algebra, just in case you want to learn more about it. And with regards to the performance, why do we have to use XLA and what is the performance boost you get there? You have, when you see throughput. Throughput is a metric where how many images can you process in a single time frame. That's throughput. So for this metric, without XLA, the performance is very bad. And with XLA, the performance is good. But if you can use XLA and grad transformation of JAX, the performance is enormous. So JAX using XLA gives you a huge performance boost. So I'll also show I have showed you a statistics, but I'll show you the code performance, code level performance of how using XLA is going to be giving you a tremendous performance boost. So is the code actually big enough for everyone to see, or should it be zoomed up or something? It is not visible. Is it very tiny? This is a slide actually. So how is it now? Are the codes visible? Not visible. So is there anything else can be done about this? The computation time and all this thing is not visible. No, right? Then it's going to be difficult. It has to be made bigger. We'll try. If not, the slides will be shared with you. If it's not possible to make it big. It's not possible to make it big. Alright, I'll share the slides with you, but I'll roughly tell you what content is out there in the slide. So, I'm going to show you the performance. The slide particularly exists because I'm going to show you the performance boost. If you do XLA, what is going to be the performance? If you compile your program using XLA, what's the performance? And if you do not compile your program with XLA, what's going to be the performance? This is what the slide is all about. Even if you don't understand the code, not a problem. It's a simple softmax function which I'm taking it. And I'm going to take this softmax function, I'm doing a JIT. So the transformation which exists for doing just-in-time compilation is JIT. So JIT is a transformation which you can do just-in-time compilation. So I'm taking the same softmax function, I'm doing a just-in-time compilation. And I'm going to see perform, I'm going to call, both the functions. So I'm going to call a function where I've done just-in-time compilation, and I'm going to call the function where I'm not doing a just-in-time compilation. So if you see the performance, the function which has done just-in-time compilation without JIT thing has taken me 13.9 milliseconds. The function where I'm doing just-in-time compilation, it is taking me 7.97 milliseconds. So without is 13 and with is 7. So it's a 50% performance boost you're getting by doing just-in-time compilation. So that's why just-in-time compilation gives you 50% boost in production time is huge. People struggle to find 1 or 2% increase in productivity. 50% increase in your execution time is a huge boost which anybody can go for. That's why just-in-time compilation is highly recommended. So that is one of the features which comes with JAX. One of the other features which comes with JAX, we have automatic vectorization. So how many of you have heard of automatic vectorization? Vectorization. Okay, what is vectorization?
Converting words to numbers.
Okay, good. Anybody else? Automatic vectorization, anybody wants to give a try? I don't have chocolates to give you, but that's for giving a try. Alright, automatic vectorization is elimination of too many loops. In a very intuitive concept, I would put it as elimination of too many for loops in your thing. You can take all these for loops and you can convert it into a dot product transformations, which makes your code very effective and efficient. So some of the, and it's also very, if you have for loop, it's very difficult to debug. You have a for loop of 1,000 loops. Which loop, which iteration is error is coming, you have to print out, put so many print statements. It's very difficult to debug a for loop. So it's always good to eliminate loops. And so this is what is automatic vectorization all about, converting your scalar implementation to vector implementation. So let's see a simple code example. You will not be able to see the code, but I'll tell you what the code contains because it's codes are very tiny. Some people at the back, if you're not able to see the codes, there's a lot of seats in the front which is there. You can come and sit in the front as well. So what the code does here is, so I'm taking a simple unvectorized implementation where I'm just taking a hypothesis function of a linear regression and I'm just trying to code it. So here on my left hand side, I have a code where I'm using for loop. I can write the same function using, I can eliminate the for loop by converting this function into a dot product function. So this on my left hand side I've got unvectorized implementation. I can eliminate this for loop by converting it by using a dot product. So I've taken an unvectorized implementation and I have put the corresponding vectorized implementation. So most of the times you can take your for loop and convert it into a vectorized implementation. So why should I even do it? Why should I even bother doing it is what we are going to see up next. So if I have to do that pain of taking a for loop conversion to a vectorized implementation, am I getting any benefit? Yes, you are going to get. So I'm going to run the function which has unvectorized implementation which has a for loop and it takes me 6.46 milliseconds. And the same function which I have converted into a vectorized thing and it's giving me 18.8 microseconds. Milliseconds and microseconds, it's a huge difference, right? 6.46 milliseconds and 18.8 microseconds per loop is like, that too for 1,000 loops each. So this is a huge productivity gain which I'm getting. So that is why it is like might be like 200 times or 300 times faster if you use vectorized code. So that's why vectorized implementation is generally recommended in your machine learning and deep learning programs. But sitting and doing a manual implementation, this is a very simple functions, but functions in deep learning are not going to be this simple. It's going to be a complex list of codes and doing a vectorized implementation for the huge chunk of codes is going to be very difficult. So doing that is such a pain. That's where JAX comes to rescue. What JAX does is very simple. It gives you a transformation called VMAP. So you use this transformation, whatever function you want to convert into a vectorized format, pass it as a parameter, it will do the automatic vectorization for you. It will do the vectorization for you automatically. That's why it's called automatic vectorization. You don't have to bother about taking all the loops and sitting and converting it to a vectorized format. JAX does it for you. It does it for you using the transformation called VMAP. And that's why this is one of the very powerful feature. You have automatic differentiation, a kind of thing in PyTorch and TensorFlow as well. So you take PyTorch, you do matrix multiplication. The corresponding, you have to add one more batch dimension to it, then you have to write another function called, there's another function called BMM which for doing batch matrix multiplication. So for every function, in order to add a new dimension or in order to write a vectorized implementation, you have to write a new function. But all this headache is not there in JAX. JAX gives you a powerful transformation tool called VMAP where you can take your unvectorized implementation, convert it into a vectorized implementation using VMAP. So that is one of the features which makes it very powerful. So VMAP, if you take vectorized implementation, all this happens in a single device. So here we are in a single device, in a single memory, how you can achieve parallelization. That is what we are, when we say VMAP, that is what we are discussing. Within a single device, how can you achieve parallelization? But what if you are using multiple GPUs? Most of the real world scenarios, how many of you work with multi-GPU environment? Multi-GPU environment? Nobody has used multiple GPUs. Nobody has used GPUs. How many of you use GPUs? Alright, good. So if you're working in a multi-GPU environment, how do you achieve device parallelization? To use multiple GPUs in PyTorch, you have to write some other piece of code. So doing all these multiple GPU configuration requires some kind of a tweaking as well. So to achieve device parallelization, you have something in JAX called PMAP. PMAP helps you do device parallelization very seamlessly. Again, you don't have to confuse yourself with much thing. Very simple. I'm taking a simple function and then same softmax function which I've been using throughout. And to do a device parallelization, I just call the PMAP transformation, pass it as a parameter. That's all. Device parallelization is achieved. So I'm only discussing the most less complicated features of JAX, but JAX is not as easy as I am explaining it. There are some complexities in JAX as well, which I am not highlighting here because this is a beginner level session. I don't want to intimidate you and do things. I want to motivate, encourage you so that all of you in this place go back and start using JAX. So there are more people in the community using JAX, that they will have each other to help out. Right now there's nobody at all. So, yes. And the final thing which I'm going to cover is about pseudo-random number generation. So, random numbers are always a very significant part of any machine learning, deep learning things which you use. So, NumPy and JAX tries to mimic NumPy as much as possible in most of the features. But in one feature, NumPy and JAX are completely different from each other. That's where in random number generation. So if you take random number generation, the underlying algorithm which NumPy uses for random number generation is called Mersenne-Twister algorithm. So this Mersenne-Twister algorithm has failed all the big tests. There are certain tests which are available to test the efficiency and things like that. So random number generation using NumPy is something which all of you use, but it's not an efficient technique at all. So underlying technique around random number Mersenne-Twister algorithm does not support parallelization. It's a very inefficient technique. But most of us don't even realize what we are realizing because we are only using the higher level APIs, right? We don't know how it is internally working and all that. That's one of the most inefficient algorithms out there, and it has failed almost all the big level tests for efficiency. But JAX uses something called a different counter PRNG algorithm. 3-5 counter algorithm is what JAX internally uses for random number generation, and this algorithm is very efficient. And the whole philosophy around this, around how the algorithm works, it supports parallelization. It sits very well with JAX philosophy of parallelization, and it works very great. As of now, this algorithm is the best we have right now. So this is one feature where JAX and NumPy completely differ from each other. So with this, we have come to the end of the session. There's also one more notebook walkthrough left. How much time are we having? 15 minutes we have. So yes, when should we use JAX? So when should we use JAX? Works very well with GPU as accelerator. TPU comes from which company? TensorFlow company? Google. So JAX also comes from Google. So TPU plus JAX, powerful combination. So there is nothing. See, normally except JAX gives 25 to 35% performance boost. When you use it with TPU, it is like very powerful. So if you are using TPU as an accelerator, JAX is the best option. And if you are using higher order gradients, JAX does this higher order gradients very nicely and very elegantly. It's a pain in PyTorch and TensorFlow. So higher order gradients, you're using a lot of it, JAX is the go-to framework. And if your speed is the end goal, speed, JAX. There's nothing which can beat speed. In terms of speed, currently there's no other framework which can beat up JAX right now. So I think if that is your startup is when goal is speed, then I think JAX. One disclaimer which I would like to do is if you're an early stage startup who have not written any code base, who are starting from the scratch, then yes, get started with JAX. But you're a startup which is already established, then you're converting your code base from NumPy to JAX. That's going to be a hell lot of problem. I'm not sure if I'll give you that recommendation because I have spoken to some startups recently where their entire code base was in NumPy. and we were having a conversation how to convert that into JAX. They have a huge code base which might come up to like, millions of, maybe 300 millions of code. Even converting that to JAX, I'm not sure, anywhere somewhere it's going to be, error is going to throw up. I'm not sure. For an established startup, transformation, I'm not sure I would recommend that. But if you're an early stage startup starting out from the scratch, then why not start with JAX if speed is your end goal? When you should not use JAX. If you're just a researcher who just wants to take an idea and see if this idea is working or not. JAX has already got a learning curve. I'm only talking about the good things about JAX. There are a lot of hidden complexities about JAX, which you will get to know if you visit the documentation. It's not as simplified and things like that. You visit the documentation, you will understand how complex the documentation is. So if you're just a researcher who wants to prototype some ideas quickly, then JAX may not be your framework. So you can just use whatever framework you're already familiar with. And if you have a constantly changing input to shapes, JAX does not support immutability as well. If you have certain paradigms which does not sit well with JAX philosophy, then it's better you avoid that. If speed is not your end goal, there are not every startup speed is the end goal, right? There are many startups where speed is not at all a concern. Then better avoid JAX. If speed is your end goal, then JAX might be your thing. If speed is not your end goal, then you don't have to go with JAX. As long as you solve your business problem with frameworks which you are comfortable with, that should do it. So, for references, I would recommend these are some of the resources which helped me in my journey of learning JAX. I really like this person, Nicholas Vadivale's JAX thing. The best resource for JAX and FLAX is the documentation. The best resource is the documentation. All the other resources are only supplementary. Some of the supplementary resources which I really liked, I have put it together, which will be given to you, which will be emailed to all of you. Now we've come to the end of the JAX session. We might have 10 more minutes to go. I'm going to quickly walk through a notebook where you may not understand every line of code. But I would just tell you what each block does. Just don't worry at all even if you don't understand every line of code, because we just have 10 minutes. We have to cover an entire huge thing, huge notebook. But you can always go back to the documentation, revisit, and try to fit it all together. So it's not that next day you're going to sit and write a JAX program. So it's just an additional knowledge for you. So just don't feel overwhelmed if you don't understand the code. So we're going to the workshop mode. So is everyone able to see the code lines? Alright. So I'll just tell you what each block of code does. If you do not understand every line of code, please don't worry at all. Is there anybody who learned a Python language in one day? No, it takes a lot of time, right? Any new programming language will take a month or 2-3 weeks. In a single day, you won't learn it. So it's very normal you see this code and if you don't understand it, it's very, very normal thing. Please don't feel overwhelmed, especially for the beginners. So I take FLAX library, any new package, it's pip installable. So I can do a pip install of the FLAX library if I want to use that. So how many of you have used TensorFlow datasets? Here I'm going to solve the simple MNIST problem. I'm sure every one of you here would have solved MNIST problem. How many of you are aware of TensorFlow input pipeline, TFDS, TensorFlow datasets? So I'm going to use a preloaded datasets. Preloaded datasets exist in most of the frameworks like TensorFlow, PyTorch, Keras. If you just quickly wanted to prototype some research paper implementation, these standard benchmark datasets already exist in all these frameworks. So we're going to take some standard benchmark datasets like MNIST, which is already preloaded for us in TensorFlow. So this piece of code, what it does is, I'm taking a preloaded dataset. The code notebook will be shared with you. Slides also will be emailed to you. So by the Analytics India magazine team. and so you don't have to worry about not executing it right now. So what this block of code does is, I'm taking a preloaded MNIST dataset which is already there in TensorFlow. MNIST is a digit dataset, right? You have digits from 0 to 9. So all these digits I'm converting and normalizing it by dividing by 255, doing all the pre-processing of this dataset in this piece of code. So this is basically a data pre-processing code. Even if you don't understand, it's completely okay. So when you take, I'm using FLAX. The reason why people use FLAX and not JAX is JAX is very core, low-level framework. So the complexity of writing deep learning codes using JAX is going to be very, very difficult unless and until you're an extremely strong programmer. FLAX makes it easy. It gives you a lot of high-level APIs, which makes it your job easier for building neural networks. So here I'm using certain features like call method, and I'm using NN compact. So using this, I can build a simple neural network. So this is just a building of, this piece of code. I'm just building a simple neural network using FLAX Linen API. FLAX has got something called Linen API, which has got, you have ReLU function, you have all this in Keras, you also have all these corresponding functions in Keras, TensorFlow, PyTorch as well. So in FLAX we have something called Linen API, which exposes these methods as well. Using that, I can put together a simple model. So this is how my simple model looks like. So it has convolutional features, ReLU, average, pooling, and all of this. It's a basic my model. And if you want to print your model summary in Keras and TensorFlow, you do model.summary. Here you can use something called model.tabulate. Tabulate is a method which you can use to see your, you will see your model summary and all, right? The same thing, you have a corresponding method to see your summary in FLAX. And so one difference is, there is a huge difference on how you do this metric and optimizer part. So in Keras, you will just call model.compile, where you will just mention all your metrics, optimizer and all these things in just that model.compile. So here it is going to be different. Here you will have to write a class which inherits trained underscore state. So that is going to be very different. You have to write a class which inherits train underscore state, and there is where you will write what your metric is, what your optimizer is. For optimizers, all the optimizers which are implemented under FLAX are there in the package called optax. So TensorFlow, you will have a different packages where all your optimizer implementations are present. FLAX has got a library called optax where all your implementation of your optimizers are there. FLAX again has got implementation of many metrics. So you have to write a custom class which inherits the train state, where you will mention all your optimizers, what metric you want to use for training, and all these parameter details you mention it here. Then I just build a method. So here how it works is, so to do a forward pass, unlike in TensorFlow and PyTorch, I don't have to write a complex bit of code. To do a forward pass, I'll just call an apply function. And then every other piece of code is going to be similar to TensorFlow and PyTorch. And this is it. So everything else is going to be similar to your TensorFlow or PyTorch code. So there are minor modifications of how you use how you do the model training and how you build your model itself and how you do your pre-processing. There are differences here, and this entire notebook will be shared with you. I think we have come to the end of this session, and so I'll stop here. If the code is overlapping, just don't worry. It's a kind of an intermediate level notebook, so it's not that nobody picks it up in a single day and nobody picks it up in a single hour. So the code will be shared with you, which you can go through it later. Now I'll open up for questions. If you have any questions in introduction to JAX, you can ask now. We'll have something. How many questions can we take? How much time we've got?